Welcome to my official YOLO-NAS course. In this course, we will learn how to detect objects using YOLO-NAS on both image files and video files. We will learn how to extract important information such as the bounding box, the class name, and the confidence value. We will start off from scratch where I will teach you how to install all the libraries we will be using in this particular video. If you are new here, do me a favor by smashing the subscribe button. You can also share this video with one of your friends. So enough with my self-promotion stuffs, let's get started. Okay fam, so let's kick off by installing all the libraries we need. So if you are using PyCharm as I am using now, then all you have to do is to go to File, then you go to Settings, then in Settings you just click on the Add Package button. So you select Python Interpreter, then after which you have to select on the plus button. So you just click on plus, and the first thing you have to search here is the super gradient library, which is the YOLO-NAS library. So super gradients, you just click on it and then specify the version, and then you click install. You can install the latest version, it also works. So that's all. I've installed it already, so that's all. Apart from this, you have to also install OPCV Python. So you just write OPCV Python. So we have to type it here, OPCV-Python. So you just click it and also install the latest version. Then you have to also install Touch. So you search for Touch and just click install package. So these are the packages we will need. Before I forget, we need to install CVZone2 to get the nice text and the nice bounding box or the rectangle. So you search CVZone and also click on install. I have installed all these libraries, so I don't need to reinstall them. That's why I just set their names. So you guys can go ahead and install them. So after that, okay, so let's for those who are not using PyCharm, to install this you just have to write cmd to pull off your terminal. Then you can use pip to install them. So for instance, you just have to type pip install, if I could spell install correctly. Then you are going to install super -gradients. You do the same thing for CVZone, you do the same thing for Touch, and you are good to go. So after that, you have to just open any IDE you are using. Then we'll start off by writing our code, and all the codes we'll be writing in this particular tutorial will be on my GitHub repository. You can leverage it and use it yourself, including all these files we are going to use. So let's quickly go through the file system. We have classes.txt, so this will be the classes file. We'll read into this code to be able to get the particular class we are detecting. So let me close it off. Then here we just have some football video of a football footage. We also have another video here. Then we have the third video. Finally, we have one image we'll be running inference onto using YOLO-NAS. So we'll look at how to run inference on images as well. So we'll start off by now importing our installed libraries. So we'll first import YOLO-NAS. So just say from, let me increase this, let's say from super gradients dot string, we want to import models. So with this you import YOLO-NAS. We'll do same for Touch. So we'll just import Touch. We'll import CV2, which is the OPCV library. We'll import CVZone itself. So we say CVZone. Then finally we also import the math module to perform some calculations. I have to import NumPy as well. So NumPy. The reason I didn't mention installing NumPy is that when you install OPCV, NumPy install by default. So in case it doesn't, you can quickly install NumPy as well. Okay, so now that we are done with our installation, first we are going to look at how we can run inference on images. So I'll just put a comment there that work images, just like that. So we are working with images now. So to run inference on images, the first thing you have to do is to get the model we are going to work with. So in this case, I'll just write our model is equal to models, and in here you have to specify the type of model you are using. So before I specify the type of model, let me just write model.get. So the function name is model.get. Then in here you have to put the particular YOLO-NAS model you are using. So just as YOLO V8, YOLO-NAS have the small model, medium model, and the large model. The medium and the small model runs faster. So if you have CPU, not GPU, you can run the small modules. But with the larger ones, you need higher computational power. So we'll be using the small module. Just type YOLO-NAS. You write YOLO_NAS, then you also write _small to show that you are using the small YOLO module. Then you have to specify that okay, you are using a pre-trained model, so you specify pre-trained weight is equal to Cocoa. So just write Cocoa here. That means you are using all the items in the Cocoa dataset, which are in the classes.txt files here. Okay, so this is how you load the model. That's all about loading the model. Then to get a prediction or to run inference on the image, you can say our output is equal to our model here. Then in here we have to pass the this thing to an image, the path to an image. So just have to run model.predict. Then you give it the path to the image you want to use. So in our case, our image is test2.jpg, so you just have to type it there because we are working in the same directory. So I'll just type test2.jpg, and that's all. So in order to show this image, all we need to write is our output.show, and that's it. So once you write this, you can run this code and you will see that we'll have some predictions. Hola, and here we go. So you can see we are having predictions: a person, a car. Okay, there is a bicycle at that side too. Okay, it's on a bicycle. Handbag, I doubt it, there is no handbag in our image. So you can see the confidence is 26, 27. So those ones are false detection. So what we can do is to specify that our confidence is we want to take all detected objects that has higher confidence. So we can specify that one too in the model.predict function. So you can type here that our conf is equal to 0.50. So anything from 0.50 above, want to detect it on that image. And boom, here we go. So you can see we have a cleaner detection now. All the false detections are gone. Person, bicycle, a car, then another bicycle at the corner there. So voila, this works great. So you can see it's very simple to run inference on images using YOLO-NAS. There is nothing hard about it. Everything is simple. So kudos for the Desi company for making this so easy for us to use. So this is all you need to know about running inference on images. But before we go, if you also have a GPU, you can then run this using the GPU by writing this line of code. You can specify that our device is equal to touch.device, and in this case we specify here CUDA. We can do if touch.CUDA.is available. So in case you have a GPU and it's available, we are going to use this. If it's not available, we can use else statement to use the CPU. So we do else touch.device, and then we specify that okay, we'll be using CPU, if I could spell that correctly, and that's it. So if you have GPU, it will go ahead and use the GPU. If you have CPU, it will go ahead and use the CPU instead of the GPU. So any of them that you have, it will choose automatically. Then you can just come here and do dot device or dot to. Then inside the parentheses you specify the device. If you have GPU, it will choose it, but in case you don't have it, will choose the CPU and work with it. So run once more and boom, so you can see we have the same result. So that's it. So this is how you run inference using YOLO-NAS on images. So we'll now move to how to run inference on video files. For that, I think we can comment this and we'll come down, and that is it. So for videos, guess what? We first need to get the video from our webcam or the video we have in our directory. We just have to read in this video file or send this frame to the YOLO-NAS module. Then this YOLO-NAS module will detect objects that it sees in this frame. So let's start off by loading in this video into our program. So for that, we create a capture object which is equal to cv2.videoCapture, and in here we still specify the path to the video file you want to use. So we want to use football1.mp4, and this is the particular video file we are reading, football1.mp4. After reading this, you have to go ahead and show. So we'll say while true, which is the same as while one. While one, we'll get our video file called a video, and this is equal to cap.read. That's it. So after grabbing the video here, let's go ahead and show it. So we use the imShow function, cv2.imShow, anyhow you call it, put it on our frame, and guess what? We are going to show our video file. After showing it, we have to wait, take it every second. So we do cv2.wait key, and we put 1 in here, which specifies that okay, we'll be taking our video frame 1 second. Each 1 second we take a video frame. That's it. So with this, we should be good to go. We should be able to read in our video file, and boom, here we go. So you can see we are reading the video file and playing it with our program. So the video file, you can see, is very big, so let's resize it. So we'll say our video is equal to cv2.resize. I want to give it a size of 1080. You can choose any size you want depending on the type of video file you are using. I will use it 740. So you want it to be like this. Let's run once again, and this time around our video has been resized successfully. So now that we've resized this video, all we need to do is to send this video to our model. But before that, I will just copy this code here for loading in our model. So I will Ctrl C and place it down here. Okay, so you can give some space here. So it's the same process. We need to load the model once more, specify the one we are using, and bear in mind the first time you run this code, to go ahead and download this YOLO-NAS small model. So you should make sure your computer is hooked up to the internet so that it will download it successfully. So that's one thing you should know. If you want to use the large model, you just have to put L here instead of the S. The medium model, then you just put M here. Okay, that's good. Okay, so now let's send this process video to our frame. So for that, we'll say our result is equal to our model.predict. Then in here, what are we predicting? We are going to predict on our video file, so we just have to send in the video file. So our video file is video. You can specify other things as the confidence, just as we do. So our confidence is equal to, we can do it 50%. and then we are taking everything as the first index. Okay, so our bounding box information, our confidence, and the class detect will be stored in this result variable here. So we can go ahead and get all these stuff from the result variable. So let's say we want to get our bounding box. So bbx or bb box x is equal to our result dot prediction. So that's it, result dot prediction. Then once you want to get a bb box, you just do it dot bb boxes, then underscore xy xy. So that's all you need to write to get the bounding box information. Now we'll move over to how to get the confidence. So we'll see our confidence is equal to our result dot prediction. So we just copy the same code since it's the same thing we are writing over and over. So result dot prediction dot confidence. So this is kind of straightforward. We'll do same for our labels. So to get our labels, which is the class names, is also equal to result dot prediction dot, then we give it our labels. Okay, so now these are all the necessary or important stuff we need from our object detection model. The bounding box, that's the position of everything that it has detected. The confidence, how sure it is that okay, whatever it has detected is this or that. Then the name of what it has detected, which is the label. So once we've gotten this, we can iterate over them and then extract the actual values. Then we use these values to draw the bounding box. So what we'll do is that we can say for, then we'll put in our bb box, our confidence, and lastly our labels. Then in zip, we'll zip it, and then we are going to zip all these three things. So we just copy them and put it in the zip function. So after this, we can just get our x1 value, y1 value, then x2 and y2. So this is equal to np.array of whatever our bb box is. That's it. So for the confidence value, we have to use the math library to convert it to percentage. So for that, I'll say our confidence is equal to math.ceil. Then in here we put in our confidence, and then all we have to do is to multiply it by 100. So when you do it like this, whatever value you get is in percentage. So if you get 50, that means 50% is 50% sure. So we are just making sure that it's in it's not a floating point value, but it is in percentage direct. Then for the labels, we can say our labels is equal to integer value of whatever our labels are, because it is float, so we have to convert it to integer. And these labels are what will be matching with the classes.txt file. So this file contains person, bicycle. So if the label is 0, that means what we have detected is a person. So let's go ahead and load in these class names here. Then we'll map it successfully. That okay, if we have detected the label here is 0, then whatever we are detecting is a person. So I'll come here and read in the classes.txt file. So let's begin with class names, which is empty list. Then we can open it as a file. So with open, we want to open classes.txt file, which is also here. So we want to open it in a read mode, so just put R here. I want to read it as F. So class names now is equal to f.read. And since we would like to put each on a different line, we will do split lines. that's it. Okay, so after reading this here, we can come down here and we say, okay, our class detect is equal to our class names in the key of our label. So if our label here is 2, it will just go into this classes.txt, then start 0, 1, and 2. That means it's a car. So we'll get car instead of the number 2. Then we know what we are actually getting. Okay, so now it seems we are done with getting all these values. We can go ahead and start drawing our rectangles on our object being detected. So I'll come down here and I'll use CV zone to draw a nice rectangle. You can use CV2 to draw the rectangle, but I just feel like the CV zone has a nice rectangle, so I'll use it. And to use that one, then we have to get the width and the height instead of x1, x2, y2. So to get the width and the height, all you have to do is write width height is equal to x2 x2 minus x1. So you are subtracting x1 from x2, and you do the same thing for y2 minus y1 as well. Then you can get this width and height, which we will use to draw our rectangle. So to draw it, we say cv0 dot corner ret, and in here we want to draw it on our video. Then we want to put it at x1, y1, then width and height. So with this we are done. We can run this code now to check whether our objects are being detected and we have a bounding box across them. But before we run it, let's also put the particular class name detected on it, so that we know we are getting a person, we are getting a ball, and so on. So we also use cvzone for that. Cvzone dot put text ret. So use the put text rectangle function, and then you specify your video, specify the text you want to put on this particular video. So here we are going to put two texts. That is, we will be putting the labels and also the class name. So we'll first put the class name, and for that you have to use f string. So we'll say f string and put it here. Then the first thing we want to put is the class name or class detect. Then the second thing we want to put is the confidence, which in our case is confidence. Then we can add the percentage sign here so that we know it's in percentage. And we'll go ahead and put the position where we want this to be. So it should be in a list. So we want to put it at x1. These positions I've checked. So we want to put it at x1 plus 8. And then we want to put it at y1 minus 12. So that will be cool. You can go ahead and specify the scale too. So the scale is 3 by default, and we want to reduce it to 2 so that it doesn't drop big on our video footage. You can play with it to get different font size of scale. And with this now we can test it by running our code. So we are getting some errors here. cv2.rectangle bb box. So that means we have some mistake on line 40. So let's check this out. Let me see. So it seems the mistake is here. We have to cast these values to integer values, because as we are getting them by default they are float, so we have to cast them to integer values so that we can use them. So I'll just come here. Before that, I'll copy wherever they are, come to the next line, paste it, and this is equal to int of bb box at index 0. Then we'll do the same to the third index. So I'll just copy and paste this and boom, here we go guys. So we are having everything working together. So you can see the players have been detected. You can see Cristiano Ronaldo dribbling other players as if they were playing. So guys, this works with only few lines of code. We are getting our objects in the video frame being detected. So all thanks to YOLO-NAS, the team, the DESI company, for doing or making this possible. We'll now continue to run inference on other video files I have here, so that you guys can judge between this and YOLO V8 which one works better. So we are out of frames, and now let's go to the top. Instead of football.mp4, we can test we have test2 there, so test2.mp4, we'll run it also. Oh, okay, so test2 is an image, so that's test, it should be test.mp4. so let's run it. That's why we got an error. So guys, this works as well. You can see it's detecting the cars. So this one feature I love about YOLO-NAS, it detects things far away before they even get closer to the camera. That means it is very good in doing that. So when it gets closer, then we get a nice detection. It's a car, truck, or we don't know. Okay, this is a car. So this works great guys. Let me have your opinions in the comment section as to YOLO 8 and this one, which works greatly. Let's run it on the final video, which is video 2.mp4. so let me run this, and here we go. So boom guys, this is detecting quite well. I'm quite impressed with how accurate it's detecting the people. Immediately you see someone, it detects. So guys, this works. This is very easy to implement. I have a tutorial session on the YOLO V8 too, how to do the same thing using YOLO V8. So you guys can watch both tutorials and compare, then let me know which one you think is better. They are all better, let me put this way, which one you think is more efficient, because I'm seeing that YOLO-NAS is performing here. I don't know for you guys, so you guys will be the judge under the comment section. So this works. I'll be sharing the code and everything on my GitHub repository. If you like this tutorial, don't forget to share it with one of your friends. Subscribe. Thanks for watching once again, and as usual, I'll see you in the next tutorial.